Welcome to students of CIP Polytechnic, CST department. In this class, we will learn kmap. Kmap is known as conclusion map. How to solve the kmap? First, try to understand some basic rules. Loop size in the kmap should be maximum. Try to avoid don't care terms as much as possible. Looping should be done for 2 or 2 to the power number of 2 to the power n number of logic ones along with don't care terms, and number of logic ones should be more in case of a loop. So before doing the k-map, we need to understand two basic things, two basic terminologies. That is sum of product. This is product of sum. Sum of product is like that: m0, m1, m2, m3. Suppose m0 is a bar, b bar, c bar. m1 is a bar, b bar, c. m2 is a bar, b, c bar. We write like that: a bar, b bar, c bar plus a bar, b bar, c plus a bar, b, c bar. These are sum of product. These are products. These are products. These are products. These are products. This is sum of products. So if we take bar of this, so according to De Morgan's theorem, it will be this OR gate, OR gate, OR gate. It will become AND gate, AND gate, AND gate, and it will become bar. So a bar, b bar, c whole bar, that means a plus b plus c bar. A bar, b bar, c bar whole bar, that means a plus b plus c. So you can write like that: a plus b plus c bar ending with a plus b plus c ending with this. So this is called product of sum. Now take an example of 3-bit and 4-bit map. So this is 00, 01, 11, 10. 00, 01, 11, 10. Here in the upper part, you can say in the column, each column 00, 01, 11, 10 we have written. 0 to 01 single bit change, 01 to 11 single bit change, 11 to 10 single bit change. This is known as gray code. In this way, we should not write 00, 01, 10, 11, because if we write 00, 01, 10, 11, it is not single bit change. It is wrong. So it is 00, 01, 11, 10. It is single bit change. So see the kmap. 4 logic ones are available at a time, so take a looping of 4 at a time. 2 logic ones remain, take a looping of 4 at a time. So your looping is done. 4 at a time, 4 at a time. Looping is done. In this kmap, for the 4-bit kmap, we have 2 don't care terms. I've told you, try to avoid don't care terms as much as possible. If the number of logic ones is high, try to conjoin the don't care terms with number of logic ones. 3 logic ones are available. 3 logic ones are available at a time here, along with the don't care term, to make a loop of 4. Here 2 logic ones, make a loop. Here this one has already been done in looping. Looping of this one has already been done. Looping of this one as logic one has already been done. So 1 logic one remains, 1 don't care term remains. So try to avoid don't care term as much as possible. Make the looping of these 2 logic one side by side. These 2 logic ones lie side by side. These 2 logic ones lie side by side. Make the looping of these 2. So don't loop 4 at a time. It is wrong, because try to avoid this don't care term as much as possible. Here we have 3 don't care terms. 3 don't care terms cannot be looped at a time. You cannot do the looping of 3 don't care terms at a time. 3 logic ones at a time. You cannot do looping of 3 logic ones at a time. You need another term. It may be a don't care term, it may be a logic one for doing the looping. So 1 don't care term is available, make a loop of 4. Here 2 logic 1, 2 logic ones are available, make a loop of 4. Here logic 1 is available, don't care term is available. So if you avoid this don't care term, looping can be done by using 2 logic ones lying side by side. Please make the loop. avoid these don't care terms. Don't go for the 4 terms at a time. It is possible, but don't take it. Try to avoid logic don't care terms as much as possible. It is possible to do the looping 4 at a time. It is possible to do the looping 4 at a time, but this is wrong. You cannot do. You have to avoid these don't care terms as much as possible. So you learn to do the looping. You have learned to do the looping. In the next class, we will learn 4 kmaps as an examples to solve, to know how to do the k-mapping, how to minimize how to simplify the higher number of Boolean logic terms into lower number of, into simplified number of terms. These are higher number of Boolean logic terms are available to you. You have to make it simple. You have to make a simple Boolean equations from that. This is called minimization of terms. K-map is used for minimizing sum of product or product of sum. In your syllabus, you need to learn sum of product only. Product of sum is not required. So, this is called our K-map.